Recording. Okay, so we're going to get started. And where we left off last week is there was something going wrong with the animation events. So if I open up, if I go down to my Toon Zombies Extended and Animation and open the Aggressive folder and click on Toon Zombie Aggressive Bite Animation Event, it'll open up the animation, and this is called, has the underscore AE at the end of it, so I know it's the one.
What? You aren't streaming in Discord.
Oh, sorry, right. Sorry. Let me share my screen. You got me now?
Yep.
Okay. So it's got TZ aggressive bite underscore AE, so I know it's the animation that's supposed to be receiving my animation events. If I hit Control 6 to open the animation window, wow, that's not what happens if you hit Control 6 in Discord. Let me get over to where I'm here. Now hit Control, select this, and hit Control 6. Okay. So I can open my window up, and I can see that if I go to my first animation event, which should be my Zombie Attack Succeeded animation event, and if I click on it, you see that the function it's actually calling is Bite Attack End, and I can't change it just by I tried typing it over, and that's not right. So I've got the wrong event in there somehow, so that's part of the problem. So let me go to this is my test zombie that we use to test out the animation. Get my scene. Double click on the zombie. We're going to click. If you remember that his animation controller is just set up to have the bite. So I'm going to go to the scene. I'm going to hit Control 6 with my zombie selected. Control 6. And as I scrub through the animation, it's going to move him to 0, 0, 0. But I can just double click on him here and it will zoom into him. And I can scrub through the timeline, and right there, I can see that it's incorrectly calling bite attack end dot underscore AE. So I'm going to right click and delete that animation event. And I'm going to click the chalk to add animation event and select zombie attack succeeded AE. And then if I keep scrubbing through here, I deleted both of them last time just to make sure, but if I click on this one, and it may be because it's not reaching that one, so let's just delete this animation event, and I'm going to make sure I'm on the last frame, and click add animation event, and select bite attack end. So I may have put it too far to the right, because you can't actually overshoot the animation. In fact, let's pull it back a little bit. Let's pull it back one frame. It's actually one keyframe, not one frame, but that's fine. Okay. So if I close that, and then I go back to my animation, Toon Zombies Extended, Animation, Aggressive, and click on Aggressive Bite and hit Control 6, I should now see that I've got Zombie Attack Succeeded and Bite Attack End correctly set up. Now, I'm going to disable my test zombie, and I'm going to let my actual zombies come and get me, but I'm going to leave my screen in editor mode, so I don't want to click maximize on play. And the reason for that is I want to see if my player's health goes down when he gets attacked. So I'm going to hit play. And it's not going down. I think the reason it's not going down, though, is because, yes, we have their damage set to 0. Let's set both of them to do damage at 5. So both zombies are selected. I click my damage 5, and that assigns that value to both of them. So they'll each now do 5 points damage every time they hit me. Oh, and I can't see it because I didn't select my player. But you see my health is going down by 5. So I got hit by one time by each zombie, and so my health went from 20 to 10, and then they stopped attacking. So We need to see why that is happening. So let's go to the zombie AI simple. So this is the second part that I said was we have to move the is attacking check. So I'm going to do shift. I'm just going to hit Control X to get rid of that. So instead of checking at the beginning of the update, we're going to check after making sure we're in range. So I'm going to click Save to save the zombie AI simple. I'm going to click Play. And it starts up once I've compiled. And my player's health is now 10, and now it's 5, and now it's 0, and I'm dead. But my player doesn't actually die. We're not going to handle player death right this second, but we are going to talk about how to give the player some feedback to let him know that he's being attacked. And then we're going to look at some other things. In the sample game that I built, when the player dies, the level just restarts. And we can set that up simply enough, but we may want to talk about how we actually want the levels to work. Also, Jack noticed something interesting, which was that the walls are 1 meter thick, but the zombie attack range is 2 meters. So, if you stand right next to a wall, and the zombie gets close enough. Let me see if I can get to the other side of it. I just did it. Anyway, you can set it up so that the zombie is attacking you through the wall, which is not obviously intended. We'll deal with that later when we add the buildings in. They're going to be significantly wider than 1 meter thick, so it should be fine. Anyway, so the next thing we want to do is we want to have the player be given an indication that his health is going down. So we're going to do our first user interface stuff. So far, everything we've done has been in the scene, in the game. But for the first time now, we're going to do the user interface that overlays on top of the game that gives the player feedback and information on what's going on in the world outside of the player and the zombies moving around. So to do that, we want to go and right-click in our intro scene, right-click and go down to UI. And as it happens, I know what we want to do is create an image. So I'm going to click image, and notice that it creates a canvas. And inside that canvas, as a child of that canvas, we have an image file. The canvas is always the parent of is the highest level parent of user interface elements. The canvas in the scene is represented by this big white outline in the scene, and my image is represented by this square right here. We're going to fix it so it doesn't look like a big white square in the middle of nothing. If I maximize on play and press play, just without changing anything, I'll just show you what happens. So I get a square just in my screen. And the canvas is going to follow along with the camera. You don't have to do anything. It'll just stay where it is relative to the player without you doing any further action, because it knows that this isn't an object that's fixed in the world. This is something you want to follow the player around because it's user interface. So the user needs to be able to see it. So by default, it follows you around. Anyway, so we need to fix a couple of things. First of all, let's rename this from canvas to in-game user interface. We're going to call it the in-game user interface to distinguish it from the pause game user interface, because the pause game will have different data elements and options and things. And we want to be able to disable the in-game user interface whenever we're pausing the game so that the interfaces aren't laying on top of each other. And then we're going to call this image here healthy. And I'm going to select this image and hit Control D. And I'm going to call this one damaged. Okay. So real quick, currently in my scene, I am sorting alphabetically You can see if I mouse over my widget here, it says I'm alphabetical order. If I search order instead by transform sorting, you'll see that damage actually comes after healthy, but alphabetically, damage comes first. In the game, this is the order that the transforms actually exist. There's the canvas, and then below that is healthy, and below that is damaged. The order of those is going to be important in a second, so I did it in that order for a reason. So if you're in transform sort, damage should come after healthy. Sometimes you want to look at transform sorts to make sure that the objects that you're trying to display are in the right position relative to each other, and in this case, they are. So, but I don't want healthy or damage to just be a white square. I'm going to go to my effects, my sprite images, and you'll see there's a player status and a player status injured, and these are sprites that I created back when I created the base game. I literally just zoomed in on the player and cut him out in using an open source image manipulation program called GIMP, and pasted him into a white circle, and then came in here and made it into a sprite. So literally nothing to that. And then when he's injured, he's red. So I'm going to go to healthy, and it says, what is my source image? And it's going to be player status. And I don't want to change anything else about this because the player status image is just going to sit there. I'm going to click on damaged. I'm going to take the player status injured sprite and drag it into here. So notice now that if I turn damaged off, then I have my healthy one. If I turn my healthy one off, nothing happens because the damaged one is in front of it. So it has to be, so the things lower in the order in a canvas's hierarchy are displayed first for the player. So damaged is lower, so it's displayed first. If I moved it, then healthy is displayed first, and I'd never see the damage. So I want the damage value to overlay it. Currently, my damage meter is full, and I don't want it to be full. I want it to be empty because I want to fill it up as the player gets hurt, right? You'll see that we have an image type, and make sure you're on the damaged image. You have an image type here. This image type can be a bunch of things, and I would like it to be filled. And I would like it to be filled from, sure, the bottom is fine. Actually, let's fill it from the top. So currently the fill amount is 1. And if I change this to 0, then you'll see my image is now completely white. And the reason for that is because my damage amount of fill is 0. So if it's 1, it's completely filled. If I slide it, you'll see that it's slowly unfilling the image and then slowly filling it back up if I go back the other way. And notice that my values are between 0 and 1. So when I'm at 0.5, I'm exactly halfway to damaged. So if the player starts off healthy and then slowly more damage is done to him, this will fill up until he is dead. So what we need to do is do a very small amount of arithmetic to determine how much damage the player has taken relative to the total amount of damage he can take. So, before we get to that, currently the transforms for UI elements work differently than the transforms for normal game objects. So a normal game object, my transform has my position, rotation, and scale. The in-game user interface transform has something called a rect transform, rectangular transform. And instead of using X, Y, and Z values for location, rotation, and scale, it uses positions, width, and height relative to a specific anchor. So right now it's anchored to the center, and if I change the position of X to 0 and the position of Y to 0, and I'm just playing with the healthy one right now, you'll see that it goes to the very center of the screen. Unfortunately, that's where my character is, so that's not going to be very helpful to us. Instead, I want it to be over here in the upper right-hand corner. Now, I can do this. If I go to... I can go into the scene, find my element, and I can drag it around manually and try and figure out where I want it to be. But what I know is I want it to be in the upper left-hand corner and then offset a little bit from the edges of that corner. Since I know I want it to be relative to the upper left-hand corner, I'm going to change my anchor from center middle. Click on this, and you'll see we've got a bunch of different anchors we can use. So I'm going to click the upper left-hand corner, and that will change my anchor. And then I'm going to change the position to 0 and 0, just so that you can see what happens. So the image is actually moved so that the center of the image is in the upper left-hand corner, because I said offset it by 0 in the X and Y direction. So I'm only seeing the bottom quarter now in the game. If I press play, you can see that's all I get to see. So instead of doing 0 and 0, I'm going to offset these by, if my image is 100 pixels wide and 100 pixels high, then it's got a radius of 50. So I'm going to offset it by 75 in the X direction and negative 75 in the Y direction. What that does is say, show me the whole image, which would be if I offset it by 50, and then give me 25 more pixels just inside the side and top. So if I press play, you'll see that my image is right there. It will do this regardless of what screen you're on, so I don't have to worry about the resolution of my screen changing and my UI suddenly being hidden. It will always do it with respect inset by 75 pixels from the top left corner of whatever I set my screen to be. And I can prove that by changing myself from free aspect to, let's say, 3:2. If I press play, notice that I'm still inset by 25 pixels in the X and Y direction for my upper left-hand corner. If I change it to 16 by 9, it still moves it so that it's still offset by 25 pixels in the X and Y direction, and is inset. So so you can do that, and the reason that Unity has this built in is so that you can design games for things like cell phones and PCs and iPads, all using the same application, and you don't have to create a unique user interface layer for each kind of device. So it's always done. It's a good practice to always do your UIs relative to an anchor of the screen so that you can accommodate any kind of display. So let me put my damaged UI in the same place. I'm going to change the rect transform anchor from center middle to top left, and I'm going to change its position from 385 to 75 and negative 75. Okay, and I'm going to change the fill amount from 1 to 0. Okay, and we need to create the script to tell the player that they've been damaged. So to do that, I'm sorry, let me check my reference here. We're going to create a new script. I'll go to our simple player, who is starting to be a lot less simple, but we're still doing a very good job of having most scripts handle only one thing, so they end up with a lot of scripts, but then we only have to fix exactly the thing that's broken, and it makes it easier to find the stuff, I feel. So I'm just going to shrink up some of my scripts here. Oh, also, did I already clean this up? Nope. The zombie animation event handler also needs to be moved to the My Scripts folder, so drag it into there, so just to keep our project clean. Go back to my simple player, and I'm just going to close these up because we're not messing with them right now. You don't need to, but you can if you want to. Okay, and I'm going to click Add Component, Player, Health, Indicator. And it's going to be a new script. Create and add. And I can double click the script here, or I can double click it in my assets folder. Again, I'm going to drag it into the My Scripts folder. So if I click it here, it'll open up my scripts and show me the one that I want to mess with. Okay, so So we're going to do a couple things here. One of the things we need to do is we need to add a new using library. We're going to add using Unity engine.ui. This will allow us to access things like images and canvases. If you don't include this using statement and you try to start typing image, nothing will happen. Text and canvas and all that stuff won't automatically complete. So if you're starting to type and your autocomplete isn't working, it's a good indication that you should check to see if you're missing a library. So we're going to create a couple things. We want to tell the player which image is his damaged image. And we want to say, we also want to make the player's health component available to the script, because we're going to use the health to determine how much of the damaged image to fill in. Okay, so we're going to need to go and get the health component for this, and we do this. We've done this a million times by now. So we do get component health. That says when the game starts, for this player health indicator script, go and get the component attached to this game object that is called health. And then we need to tell the game. Let's create one more float here called public float my health percentage, because that's what we really want, right? We don't want to count because of the way we're displaying the damage. In this case, we're doing a health percentage, and when he's at 50%, we want it to be 50% filled in. When it's at 99%, we want it to be 99% filled in. So it's a percentage. So down here in the update, once per frame, we want to go and calculate health percentage. But this is a very easy calculation, so it doesn't matter that we're doing this 60 times a second. It's a kind of calculation that the computer can do trivially. So we're going to say my health percentage is equal to my health dot my max health minus my health dot my current health, and I'm going to put parentheses around that expression, and we're going to divide the whole thing by my health dot my max health. So let's talk through what this does real quick. The player has a maximum of 20 hit points. If the player's current health is 20, meaning it's got all of his current hit points, then his max health is 20, his current health is 20, and his max health is, and we're dividing that by his max health, which is 20. So 20 minus 20 is 0. You divide it by 20. 0 divided by 20 is still 0, which means that the damage that needs to be filled in is none, which is correct. Because if you have 20 hit points and your maximum is 20, you haven't taken any damage. So 0 is the correct answer. If my player has taken 20 points of damage, then my current health is 0. And my max health is still 20, because my max health does not ever change yet. It will eventually change when we have the idea of levels or bonuses that will increase his maximum health. But for right now, his max health is 20. 20 minus 0 is 20, and 20 divided by my max health, which is 20, is 1. So it will be between 0 and 1. And then you can go through all the other permutations. If your current health is 10, 20 minus 10 is 10. 10 divided by 20 is 1/2. And so it will fill in the value of 0.5. So let's save this. And we're going to press play. Zombies are coming in. And they're biting. And even though they're biting, my health is not filling in. My damage is not filling in. So why is that? Oh, because, well, actually it's two things. First thing is, in Simple Player, we never told it what my damaged image is. So we've got to go to the in-game user interface, Simple Player, and let's drag the damaged icon onto the damaged image. That's one thing. The second thing is we never told it to update. So let's go back to our script, player health indicator, and you'll see my damaged image dot fill amount is equal to my health percentage. Okay, so this is now saying go into the, let's save this. If you go to the image, you'll see right here there's a thing called fill amount. I've also got fill origin, fill method. I can change the image type. Anything that's in these default things, Unity gives you access to. So I have direct access to the fill amount just by going to image.fill amount, and I can fill in as much as I want. So let's try this again now that we've got that all saved, and now the damage should be reflected when the zombies come and attack. Bite. Okay, you can see the attack succeeding. Okay, so what happened there? It went from nothing to full. The reason it went from nothing to full has to do with the data type that we're using for health. One of the things we established very early on in our game, way a long time ago, was that health, let's open up our health script, health is integers. So all damage that's done, you can't do fractional damage. You can only do a whole point of damage. So what the player health indicator is doing, it's doing integer math. And it's saying, okay, when your current health is 20 and your maximum health is 20, that resolves to 0, and 0 divided by 20 is 0. When your health is 10, so you've taken 2 hits of damage, we'd expect the damage meter to be halfway filled up. But instead what's happening is it's saying your maximum health is 20, your current health is 10, which makes a difference of 10, and that's a fraction, so I'm going to leave it at 0. And it's not until the value reaches 1 that it actually changes the value. So basically it's doing integer math in that it can only return an integer. It can only return 0 or 1, and that's not what we want. I don't want to go back and refactor and make all the health values floats because I want them to be integers. I want them to be whole numbers. So what we're going to do instead is we're going to cast, for the purposes of this equation, we're going to cast these as float values. And we do that just by putting parentheses, float, in front of each one of these values. And remember, my health percentage, when we created it up here, we already said this is a float. Now it's saying treat all of these values like they're floats. So don't do integer arithmetic on it, do float arithmetic. And float arithmetic can result in decimals, which is what we want. So I'm going to click save, come back to the game, and press play. And when I get bitten, I lose a quarter of my health. I lose another quarter. So I'm dead. So now it fills in. Right now I can get hit only 4 times before I die. So let's make it a little more unfair for my zombies. And let's take one of the zombies and have them do a little more damage. We're going to take one zombie here and have it do 8 points of damage. So it's not going up in a fixed amount every time. So you can just see that the difference that the zombie does makes a difference. Okay, so you can see now that it's slowly filling up, and it goes by a different amount depending on which zombie is attacking me. In fact, let's make it a little more obvious by making one of them do 20 points of damage. So when I get hit by one zombie, it'll go up a lot. When I get hit by the other zombie, it'll only go up a little bit. And I can help them out a little bit. So now I can see that one of my hits is doing a lot more damage to me, and I can prioritize killing them. Okay, so that's the basics of how you do a health indicator. Anyway, the way that I want to do it for this game. You can do it all kinds of ways. You can have bars. You can have other kinds of things that fill in. You can have a more complicated graphic that fills in and isn't necessarily a solid image. So you can do all kinds of things with it, but that's the basic gist of how you communicate to the player that they're being hurt. We are going to eventually put in logic of what happens when a player dies. We're just not going to do that right now because I want to focus on some other things. So, now that we've got the player's health sorted out, there's another thing we can do which will, I think, make the health indicator a little more interesting and dynamic, and that is cause the image to start to pulse when the player gets low on health. So I played around with this a little bit this weekend, and so we're going to just continue working on our player health indicator, which right now is a total of maybe 2 actual commands and 6 lines of code. So we want to introduce some more variables. We're going to introduce a public float called my slow pulse rate. Public float my fast pulse rate. Public float my slow min size. Public float my slow max size. Public float my fast min size. Public float my fast max size. Public float my current min size. Public float my current max size. Public float my current rate, pulse rate, and public float my current size range. Okay, that was a lot of typing. I'm going to actually put a return character here just so I can separate the logical units of what I'm working on. So basically what we're going to do is we're going to say that if the player's health is relatively high, then nothing is going to happen. But when the player gets down to half health or lower, the player's health should start pulsing. And when the player's health gets down to less than a quarter of his health, it should start pulsing a lot faster and more noticeably. So, we've already calculated the health percentage in this script, so we don't need to calculate it again. So, we're going to say if my health percentage is is greater than 0.5, because remember, that's the amount that you've been damaged. And my health percentage is less than 0.75. Remember, we have to end these numbers with F's because they're floating point numbers. Then we're going to say my current min size is going to be equal to my slow min size. My current max size is going to be equal to my slow max size. And my current pulse rate is going to be equal to my slow pulse rate. Okay, so if I've taken enough damage that my health percentage is somewhere between 0.5 and 0.75, and remember that's the amount you have been damaged, then I want to set all those to my slow values, and else if my health percentage is greater than or equal to 0.75F, then I'm going to just copy this block of code, Control C, Control V, and change slow to fast. Slow to fast. In my selection, yes. Okay. So what I did there is, so now we're going to set current minimum size to the fast minimum size and the maximum size to the fast maximum size, and the pulse rate to my fast pulse rate. And we'll get into what all this is going to do here in the inspector in just a second. And then if neither one of those is true, then my health is relatively normal, and I don't want to pulse at all. So I'm going to set my current min size equal to 100. My current max size is equal to 100, 100, and my current pulse rate is equal to 0. Can it be? Nope. It needs to be a float. Equal to 0. Strictly speaking, you don't have to include these 0.0f's. I'd like to remember that they're floats so that I don't later come back and say, why is that an integer? So, okay, so what this says is, if I get damaged some, cause my image to pulse using my slow parameters. If I get damaged a lot, cause it to pulse using my fast parameters. And if I'm not damaged that much, then don't cause it to pulse at all. Okay, so after it's done that calculation, then we want to set my current size range equal to my current max size minus my current min size. So that's going to generate a float value that is equal to the difference between my current maximum size and my current minimum size. And maximum and minimum size have been set based on what my damage currently is. Also, this is a really bad practice. What I've done here is I have baked in what are called magic numbers. They are numbers that are in a script that don't correspond to anything. I did it up here too. The reason I'm doing that right now is because I'm okay with putting in some magic numbers so that I can demonstrate the concepts, and then we can come back and replace them with variables later. You never want to have a script that has numbers that are baked into the body of the script, because there's no way for you to see in the inspector what they are, and there's no way for you to change them short of changing the code. And so if you have a number and you might want to change it in the future, you probably want it to be a variable if it's something that might vary. Okay, so but right now I'm going to leave the Amaru, my this is bad comment. And then we're going to do a really long command. This is just a lot of typing. So my damaged image dot rect transform dot set size with current anchors. We don't want to change the anchor of the image. We just want to change the size of it. Rect transform dot axis dot vertical. So this is saying change the size of my image in the vertical only, in the vertical direction only. My current minimum size plus math f dot ping pong time dot time times my current pulse rate, comma, my size range, current size range. Blech. Okay. Take my damaged image, find its rectangle transform component, set the size of that component with the anchor that it already has in the vertical, because remember in an image we have a vertical size, which is the height, and we have the horizontal size, which is the width. So go to the vertical, and then take whatever my current minimum size is, and then I want you to ping pong, math.pingpong. Let me talk about this for a second. Ping pong slowly changes the value from it so that it is never larger than the value that's in length, and it's never smaller than the value of 0. So it will bounce back and forth between 0 and the size of the range. So I'll explain this more when we get into actually putting some values in, and we can substitute some numbers in here and see how it's working. But basically, math.pingpong represents the fact that programmers often need values to cycle smoothly between two given values. Math.pingpong is how you do that. And then we're going to copy this, Control-C, Control-V, and we're going to change just this one word here from vertical to horizontal. So basically I'm saying change the size in the horizontal and the vertical by the same amount every time so that they stay in sync, because that's what I want. I want my image to grow and shrink in the horizontal and vertical at the same rate. You can make them be out of sync if you want to, and it will look funky and weird, but maybe that's what you want. I don't care. Okay, I'm going to click Save. I'm going to leave that up on the screen for a second. In fact, let me just copy and paste this down here because it was so much typing into the chat. If you want to grab it out of there, if you haven't had a chance to catch up with everything. If there's anything else that you need me to copy and paste, because I also know that I wrote a lot of floats up here. Let me know, and I'll drop them into the chat as well. Okay, so make sure everything is saved. And pop back over to Unity. And let's go look at our player. Okay, and see, all these values are set to 0. We're not going to mess with health percentage because we know the script is going to set that. For my slow pulse rate, we're going to want to use, let's say, 30. And you'll see, we're going to play with these numbers in a minute, so you'll see what they can do. Set the fast pulse rate to 60. Slow min size set to 90. Slow max size set to 110. Fast minimum size, I'm going to set to 80. And fast max size, I'm going to set to 120. And then I don't need to set the my current because those are all set in as the game plays. And again, I've set the zombies up so they do a bunch of damage, and so we should be able to watch our character progress through 50%, 75%, and on to 100%. So here we go. Press play. And again, I want my character to take damage. This is not time for me to worry about shooting the zombies. Okay. I start taking damage, and nothing is happening for some reason. What changed? Let me turn maximize on play off and see if I can figure out what's going on. So okay, I can see my health percentage is going.
It kicks in with the red at about, I would say, half is when mine started to kick in, and then your pulsing does start to work.
Yep. Okay. So
I think it's because your current min and max size.
Yeah, I left my current min and max size. Well, it should be setting to 100 though, right?
Oh, yeah.
My health is less than 0.5. Then my current minimum size should be 100. In fact, let's go ahead and replace these with variables so that we can actually see what the values are. So public float, my default min size. Actually, you know what? Let's do. Yeah, let's do it. My default min size public float, my default max size and public float. Oh, I bet it's because it's doing it to 0. My default pulse rate. And then we're going to take those values and replace our defaults. My default pulse rate. I will bet that it's because my default pulse rate is set to 0, so the current pulse rate is going to be 0. But my size range should be... Oh, my size range is 0 too. Okay. I'll tell you what, rather than trying to trick the ping pong into not moving, let's say... let us, in fact, get rid of all of those. Well, no, we're still going to need them because we're going to want to reset it. Let's create a Boolean called isPulsing. Okay, and then we're going to set isPulsing is equal to true in the slow block. We're going to set isPulsing is equal to true in the fast block, and we're going to set isPulsing equal to false in the default block. And will that work? That'll work for, that'll work for most of it. We're going to have to do something else later on when we introduce health drops, but for right now. Then we'll do if isPulsing. Then do all this stuff, and otherwise don't pulse the health. So let's try that. Yeah, so what I was doing was the range was 0, so it was making it a size of 0 and not moving. And what I need to make it do is make it a size of 100 and not move. But there, now we can see our health coming in, which is what we want. And that sort of alerts the player that things are getting dire. And now it's really turning into a big deal. Okay.
So wait, so you changed, I'm just double checking, so after the isPulsing, what did you change? So you did isPulsing is true in both the first and second ifs, and then in the final else you made it false.
Yep.
And then did you do anything else after if isPulsing? Okay, sorry, thank you.
Okay, that's fine. So, so one of the things that you may notice is it's actually pulsing at sort of the same rate. The reason is because it's going over a much wider range in the same amount of time. So leaving the fast pulse rate at 60 is actually not working for us because the it's about the same as the normal health. So let me just do this here. I'm going to press play. I'm going to manually mess with this health. So if we take this down to 99, it's pulsing at that rate. Let me just pause my zombies because they're not going to help. They're going to get in the way of what I'm trying to do. Okay, so it's pulsing at a specific rate here, but if I go to his health, so look at that rate for a second so you can kind of get the image of what it is. And if I set it down to 20, it's going at the same rate, it's just more. But what I really want it is to be doing is pulsing faster, so the player becomes, increasingly alarmed. So let's change the fast pulse rate to, let's say, 120. And I'm going to disable my zombies because I'm just going to do this manually. Simple player, press play. Set its health down to 74. And it's pulsing. If I set it down to 20, then it's really pulsing a lot and becoming more, intense. Also, another effect we can do, we can add in. So that's what I want that's how I want the effect to work. It's going to be faster. It's going to pulse more, and it's going to communicate to the player things are getting worse. Also, we can go into the healthy image, to the damaged image. They're in the wrong order because I'm using alphabetical sorting, not transform sorting. And notice that the color here can be changed. So I can take the color and I can make it sort of a bluish color. Okay. So let's go to my filled in amount. And so my health is blue. What it does, though, is it colors the image the color that I'm specifying. And because I already colored it red in the photo editing application, it's trying to combine the red and the blue, so that's why you get a black outline and a weird blue background. I can change it to whatever I want to. I can make it yellow, or I can make it even more red, like a dark blood red, if that's something that you're happy about. I can also make it transparent. So I'm going to take the transparency down to here. And if I do that, and then you press play, nothing's going to happen because there's no one in the game but me. But I'm going to take his health down. And now when it pulses, it sort of feels more like there's a warning around your character. And in fact, let me undo that. So I'm going to take my damage here and set it back to white. And I'm going to set the alpha all the way back up. We can create even another image in the background that will create, that will pulse along with it and give it cause it to pulse as well. And you can just keep going on and on and on with this. User interface stuff is like particle effects. Once you start playing with it, you'll want to just piddle with it for hours. So for now, let's leave that and switch gears a little bit, talk about a different concept. I've been going for about an hour, and I would normally aim for about 90 minutes. You guys got another half hour?
I do. All right.
Yeah.
Okay. So I'm going to shift gears a little bit and start talking about how to make the game just look different. There is a series of effects that we're going to want to apply called post-processing effects. We also want to change the lighting. Right now, this game takes place in the middle of the day. It's just after 2 o'clock, I think. And you can tell that by the shadows and by the position of our directional light. Let's go to our directional light. Remember, the directional light is the sun, so it doesn't matter where it actually is in the world, but you can rotate it, and you'll see that the time of day will appear to change as the length of shadows changes. Okay, but we don't want the game to take place at about 2 in the afternoon. We want it to take place, I'm going to say at night. For the purposes of this level, let's just have it take place at night. So we can change a couple things to make that happen. First of all, we can actually change the directional light to be, instead of being this light yellow color, we can go to our directional light, go to color, and change it from yellow to blue. And I'm going to drag this over here. So just doing that makes it a little more nighttime-y, sort of. We can also turn down the intensity of that light from 1 to 0.2. And that has some effect, but notice that it's still pretty well lit. The reason it's pretty well lit is because there's also a global lighting effect that's being applied that is not in our hierarchy. It is in the lighting tab, which we're going to look at right now. So let's go to Window, Rendering, Light Settings. Lighting Settings is the first column, row in the Rendering tab. That's going to open a different window for me. So right now it says the skybox material, where's the sun source, where's your environment lighting come from? And it says environment lighting is what's messing with us. The environment lighting, we actually want to come not from the skybox, but a color. So we want to set what the environment lighting default color should be. You can make it come from the skybox, and you can actually get some neat effects doing that. But for right now, let's just make it using a color. So instead of making it gray, why don't we make it a really dark, rich blue and head it towards... There we go. And we can... we don't need any of that. Yep. So that's going to do it for us. Let's make it even darker. You can make it basically completely black, but I'm going to make it pretty dark. Nah, I'm not going to mess with that. Set the effect to 0. Okay. Click OK. And I can turn this down to 0.1. Okay. Now if I click play. Okay, now I have a much darker looking world. And that's great. I need to turn my zombies back on. Sorry. But what I really want to do is I want the player to have a flashlight where he can see the world around him better in the direction that he's facing. I don't want the zombies to be invisible behind him. Because that's not fair. Because the zombies would just win every time. But I do want them to be easier to see in the world where the flashlight is shining. So to create the flashlight, I'm going to do the easiest thing in the world. I'm going to grab my simple player, and I'm going to right-click on him and do Light, Spotlight. And notice that right off the bat, without changing anything else, he gets kind of a spotlight, kind of a flashlight effect. Press play. Maximize on play. It's not great yet, but you can see that it's kind of lighting the area up a little bit, and I can kind of see the zombies a little bit better. Not really. The reason it's not being very impactful is that the light isn't very bright yet. So let's take the spotlight and change its intensity from 1 to, let's say, 5. 5 is kind of ridiculous, but still. I also want it to intersect with the ground more, so I'm going to drag the handle of the radius and expand it out. So I can see in front of me. Press play. Okay. And now it's starting to look a little more like an actual flashlight. I can see the zombies much better when they're right in front of me. I probably want to extend this a little bit because it's not really as far as I want it to be. So I'm going to navigate in space. I'm going to grab this center handle and drag it out forward so that I can see a lot farther. And the farther I drag it, the more I can see. So, press play. And now I can see the zombies in front of me really well. And so I can kill them to death. But we do have a little bit of a problem, which is my flashlight works through walls, which is not, ideal. So, we're going to go to the light, and you see right now it's casting no shadows. That's the reason it's able to go through walls, because none of the objects in the scene are creating shadows. Instead, let's create hard shadows. And now I'll get very stark shadows when I go around corners looking at the wall. But I'm also getting a weird glitching effect. So what is that about? What that is about is that my player is occasionally actually getting in front of the light. So let me pause this. Let me show you this a little more clearly. I'm going to turn the lighting switch off in the scene view so that we can more clearly see what's happening. Okay. So I'm going to turn the zombies off for a second because this is more of a lighting thing. So if I press play, pause, go to my, okay. So when I'm running, I'm going to go forward. Okay, I need to select my light. I'm going to run forward, hit Control-Shift-P. Okay. So let me grab my light here in the thing. All right, this will more clearly show it. So notice that my light is bounded by these yellow lines in the scene view. And as I step forward, I'm no longer pressing forward, so it doesn't know what to do. Having a really hard time demonstrating what I'm trying to show. Basically, the animation is getting in the way of the light because the light is coming out of his belt, basically. So we can make the light come from a different place on him, but coming from the center of him will definitely illuminate what we want illuminated. So I don't want to move it. So instead, I just want it to ignore the layer that the player is on. So let me go to my player and see what layer he's on. He is on the default layer. Well, what layer are my zombies on? They're also on the default layer. What layer is my wall on? Also on the default layer. So why don't we move our player to a different layer? We're going to add a layer called player. And then now we're going to hit play. Okay, so I moved the player to the layer, but didn't change the light. So let's go down to the spotlight. And in its culling mask, right now it's saying, the culling mask says, ignore everything but this thing. And I want it to ignore everything except the player, right? So I'm going to select default. Now, as my culling mask, meaning I'll ignore everything except for the default layer. And I can, in fact, pick everything and just uncheck player. And we get the culling mask of mixed. And so this will say, ignore everything, every layer except for post-processing UI, water, ignore raycast, transparent FX, and default. Really, though, we just want it to ignore everything but the default layer, because we don't want it to interact with the user interface. We don't want it to interact with transparent effects. So just leave the culling mask as default. Ignore everything but the default layer. Now if I hit play, we should see that our weird artifacts are still there. And I can definitely see that my player is receiving shadows. So why is that still happening?
I think
why don't we move the...
But you didn't actually put the player on the player layer.
Oh.
Yeah. So let's do yes, change children, and then that will change the spotlight too, but I think that'll fix it. That's right. Thanks, guys. See, that's why I keep you around. And now we've got a nice, smooth flashlight that works exactly the way we think it's going to. The problem with moving it forwards and backwards relative to the player is that you can get a situation where the light is being blocked by a wall behind you or in front of you. So this looks pretty good.
What I was thinking is we would move it up towards where his head is and have it look down. Kind of angle it down a little bit to compensate for that.
We can do that.
It's funny though, because I was playing with the light off, and once you turn the big light on, it makes you feel like you've got a higher sensitivity because your movements are so much more exaggerated. Which are interesting.
Yeah.
Which is interesting.
So we're getting some weirdness, but we can live with it. The big thing is that I wanted to communicate here is that lighting isn't going to undo that because I like it as a felt. But you can do whatever you want in your game. What I like about what I'm trying to communicate here is that lighting can really change the way the game feels, and it looks a lot different now than it did when we started this evening. I do want to go and get one resource off of the internet. So let's grab a browser window. And let's go to, let me see here. Let me get a, okay. So I just searched here on Unity Cookie Flashlights, or Unity Cookie Flashlight, and I'm just going to you can grab any one of these images. They would all be fine. If you look at Light Cookies Variation 4, I like the look of that image. So I'm going to right-click on this image and save image as. I'm going to go down to my game dev folder, and I'm going to save it in session 8, which is the one I'm working on. Assets, my effects, my sprite images. Save. And I'm just going to close this window. Okay, so a cookie is a mask that you can put onto a light that will make it look more like an actual light. You can do all kinds of neat things with cookies. You can make the caustics underneath water be projected so it looks like you're underwater. You can project effects down onto the player. What we're going to do is make this look more like a flashlight. So I'm going to go into my effects, my sprites, and I've saved this image here. You can get any one of those images. All of them will work just fine. I just think this one's kind of interesting looking. I'm going to change the alpha source from input texture alpha to from grayscale. And I'm going to click apply, and you'll see that's going to, and I'm changing it from texture type default to cookie. And click apply. Hang on. Do I need to make it a cookie or a sprite? I do need to make it a sprite. Okay. Let's go to apply. And okay. So let's go here. There we go. What was confusing me is it wasn't applying the alpha or transparency based on the grayscale, which is what it's supposed to do. So I'm going to go to my light, and you'll see it's got a spot here for cookie texture, and I'm just going to drag my spotlight sprite light onto here. And I'm just going to press play so you can see what this does. So now my light looks more like the light coming out of a flashlight. It's got a hot spot in the center, and it gets blurrier out to the edges. So that is a little better looking, I think. So let's turn my zombies back on, run through the game one more time. Okay. You'll notice we're still getting some weirdness when the light's on the move around certain things. And the reason for that is because it's trying to calculate the hard shadows for the lights in real time, and I'm moving a little bit faster than it can keep up with, maybe. So we're going to minimize that by having the things in the scenes be not so thin, which will help. We're going to have these big Russian buildings. But I do still like the way that it's lighting up the zombies. I think it looks pretty good. So, okay. So, and then finally, we want to play our creepy music. So I should go to my sound effects, and do I not have my creepy music? If I had a, No, I do. Horror music. Okay. So there's a folder called Horror Music, and there's a loopable clip in there called Intense Chase Loopable. This is a free clip of music I found online, and we can play it and actually preview what it's going to sound like. Can you guys hear that?
No, we can't.
Well, then there was no reason for me to let it play for so long. Okay. So, I wonder why you can't hear my... Well, that's the problem I can solve another time. But basically, there's a song in here that's a short piece of music that will loop that we want to play in the background. To do that, we need to add a very simple piece of built-in functionality because they realize that maybe you always want to have something playing in the background. Click on a simple player, and we're going to add a component called audio source. Sorry, don't do that. Undo that. If you've done that, undo it. We actually want to attach it to the main camera. Audio source. There we go. The problem with attaching it to the player is that we're going to want the player to make his own sounds later, and you don't want the music to being interrupted by the player's sounds. We want the music to play constantly in the scene. So attaching it to the camera means it will just always be there for us, and there's nothing else we need to do about it. The audio clip I want to play is this Intense Chase Loopable, so I'm just going to drag that into audio clip. I'm going to click play on, make sure that play on awake is checked, and I'm going to check loop. So when you play this initially and press play, it's going to be pretty loud. Or it may be louder than you think it's going to be. So press play and see if you can hear the music playing. Can you guys hear the music playing on your side?
Yeah.
Okay. That's a little too loud because the player will get annoyed with you. And we want to have things like gunshots and bite sounds and other things playing. So we want to play it in the background. So instead of having it play at a volume of 1, let's have it play at a volume of 0.2 and press play and see if you can still hear it. So you should still be able to hear it, but it's much less intense, and we can actually do stuff with the volume based on the player's health. We can make this intense chase loop get louder as the player takes damage. We're not going to do that right this second, but that's certainly something we could do. Another thing I want to show you is we can also change the pitch of the song. So instead of having it as 1, change the pitch to 0.85 and press play, and notice how that changes the song.
It's much slower.
Yes, it's much slower and it is lower. Let's make it to 1.3 instead and press play. So the point of that is to show you that you can change the pitch of any sound cue to make it lower and slower or higher and faster. And there's times that you're going to want to do that. And one of those times is right now. So in our simple player, we're going to need to create a new component called audio handler. Add. And we also want to add an audio source for the player. And don't change anything on the audio source right now except for unchanged play on awake. Leave everything else just empty. We're not going to add a specific clip in here right now. We're going to handle which clip we're going to play in our audio handler source. So I'm going to go audio handler. And I'm going to, first thing I want to do is do public audio source, my audio source, and in the start function, my audio source is get component. Audio source, go get the audio source component associated with this character. Okay, and we're also going to create a public audio clip called my shot sound. And we don't want this to play during the update, but we do want to create a new function called public void play shot sound. And we're going to do my audio source dot play one shot, and you have to give it a specific audio clip, my shot sound. So what this does is every time someone asks me to play the shot sound, I'm going to play exactly one time the audio clip that you have defined in my shot sound. Okay, so what piece of functionality should call play shot sound? That sounds very much like a job for the shot handler. So I'm going to open up the shot handler script, which we haven't messed with in a while. And I'm going to create a public audio handler. My audio handler. I'm going to say my audio handler equals get component. Remember that back in the beginning I typed in game object every time, but you don't need to. You can just type in get component and it knows get the component for this game object. Audio handler. So go and get the audio handler script associated with this weapon, with this player, this object, game object. And if the player presses fire 1, then I want you to shoot, and I want your audio handler to play shot sound. Okay, I'm going to click save. Come back over here. And the reason I'm specifically calling it my shot sound rather than my audio clip is because we want to differentiate different sounds that we want this audio source to play. But right now, the only one we care about is going to be a shot sound. Go back to my sound effects, and there's a bunch of different sound effects you can play in here, and you can click on them. The handgun HP30L 9mm fire RR2 stereo is the one I'm going to use. You can use any of these. I've got a couple of different things in here. The assault rifle sound much bigger and beefier, and various of the handgun shots sound louder or quieter depending on what you want. I'm going to use the very last one that says Firearm Handgun H P30L 9mm Fire RR2 Stereo. There. Okay, go back to my simple player, and I'm just going to drag that sound effect into my shot sound. Okay, so I'm going to click play, and I'm going to press the shot button a lot. Oh, the wall bleeds blood because we tagged it as a zombie a couple of lessons ago. I'll fix that in a second.
I think that would definitely be a fun version where the walls bleed and the pistols sound like bites.
So,
like surrealist game.
Yeah, you can do that. So that's great, but that sound is going to get irritating pretty quickly because the player's going to hear it over and over in the exact same tone and pitch a lot. So what we want to do is, what I like to do is to vary the pitch randomly, so that the player gets a little bit of a different sound. What's this one? Okay, just another one. Gets a little bit of a different sound every time they fire the gun. So I'm going to go back to my simple player, go find my audio handler script, and in play shot sound, I'm going to say, let's create a couple of floats here. Public float, my shot min pitch, and public float, my shot max pitch. And then I'm going to come down here and say float my shot pitch is equal to random dot range my shot min pitch, my shot max pitch. So I'm going to say, give me a pitch valued somewhere in between the minimum and the maximum, and then play the shot of that sound. The way I do that is I say my audio source dot set dot pitch is equal to my shot pitch. Now you do have to remember that you're doing this, because what can happen is you'll want to play a different sound, and the audio handler will be pitched up or down because of the pistol you just fired, and your player will sound like a munchkin if you're trying to play a voice thing. So you need to remember that you're setting the pitch randomly in one of your functions. So there's a couple of different ways you can do this, but this will work pretty well, and you'll be able to see the effect pretty clearly. So I'm going to save, come back to my game, let it compile, and I'm going to take my minimum pitch and make it 0.5. I'm going to take my maximum pitch and make it 1.5, which is a gigantic and ridiculous range, just so you can hear the difference. And then when you press play and you start shooting, you can see that you do indeed get a lot of different pitches of your gun, but some of them sound absurd because the range is just way too big. So I'm going to go to my simple player. Instead of making it that large, I'm going to do 0.9 and 1.1. 0.1. Press play. And I still should get a variation in my shot. But it's not so dramatic. And you can play with it and make it wider and louder if you want to. Or, one of the things you can also do, let's say you just decide you want to pitch this thing up all the time. You can set them both to be pretty high and press play. And you'll get a smaller sounding gun. And that's something you can do. Also, if the music is bugging you, because you're going to hear the first few bars of your music a gazillion times, remember that it's on your main camera and you can just turn it off if you're turning the audio source off if you don't want to listen to the music every single time you start the game. You will get tired of the first few bars of your theme song pretty quickly. And remember that your players are going to not experience it that way. They're not going to hear the first few seconds over and over. Anyhow, so the player, I'm going to make this 0.95 and 1.05, 1.1. And those will be fine for what we're going to do. And I've only got 7 minutes left. I think I'm going to stop there for this week. There's a couple of other things we want to introduce. We want to make the zombies make a noise when they bite. We want to do a little animation over the zombie's head with a sprite to indicate they're biting, just to make it clearer to the player what's happening. Because right now they're kind of lunging at the player, and it's not, maybe you can't see that they're biting because of how high up we are. We want the player to die when his health gets down to 0, and we want the level to restart. And we want the player to be able to pick up health items that will help him. And once we've done all of that, I think that's everything in the base game. In fact, the health thing is going to be new functionality that I didn't have in the original demonstration. So play around with it and do whatever you want to with it. I'll send out this version of the file. File save project. I'll send out this version of the file with my notes this week, and I'll put this video up online. In fact, let me stop recording because we're all done there.